Friday, May 31st, not quite 8:30. Ooh, that's not a good sign. There's quite a bit of dissipated chemtrails out this day, so I'm a little bit concerned about the quality of the transparency of the sky. And I noticed when it's up there, I get a bit more pixelation. I'll have to confirm that on the screen. You can see a cloud off to the west, a few clouds down into the south, that huge chemtrail going across the sky there. Some might object and call it a vapor trail, and it's possible that it could occur under unusual conditions, that vapor trails would extend all the way from horizon to horizon, but I kind of rather doubt that. I suspect, and I've heard more and more, even on conventional media now, about the use of chemicals in the atmosphere to reflect away more sunlight as a result of the heating up of the Earth's atmosphere due to human-caused climate change. I know some very intelligent friends who object to calling it human-caused or humanocentric, but any kid with some couple of bottles and some black cardboard and a nice way of measuring the temperature inside a glass bottle with a little dry ice melting in it and exposing it to sunlight with a comparison bottle that has none in it will probably notice the temperature rise more quickly in the dry iced bottle than in a normal atmospheric bottle. It's an experiment I probably should do at just about every science class beginning middle school. Anyway, if anybody does it, let me hear about your results. Standard startup procedure, warm restart, go to the time, count to 1001, 1002, 1003, because it gains about 3 seconds every day. Tonight we're going to start, hopefully be able to recapture a few of the galaxies that are westering in Coma Berenices. And the idea, I should park it at the CW position first, and then go, back. And then I'm going to proceed to the east, probably passing through Butes, as well as going into studies in Corona Borealis, and then park it at a home position, which I've set off over here, and then into Hercules. Interestingly enough, I went through the Wiltarian Sky Atlas expecting to see a lot of brightish galaxies in the constellation Hercules, and there were very few, so I had to go online and see what I could turn up. Anyway, another hour and a half before sky dark, and we shall proceed then. Carpe diem. Well, now we are at the beginning once again. Discovered this galaxy, NGC 4485, in its brighter confrere 4490, while touring Canis Venatici earlier in the month. Wanted to give you the data on NGC 4485, the fainter galaxy, and I've reported that a little investigation turned up. The reason we do not see such a bright core in 4485 is because its black hole nucleus was probably absconded with by 4490 when 4485 and 90 had a collision millions of years ago. NGC 4485's galaxy in Canis Venatici, magnitude 11.9, 2.4 by 1.8 arc-minute football-shaped irregular galaxy, 22 million light years distant. Pretty small galaxy, probably about 20,000 light years in diameter. This is a better view than I've gotten previously because I've discovered that I was on zoom mode last night, which I reported in a previous observing report video, And in that report video, I felt that there was a doubling of the normal magnification from 75 to 150. I did a little check using my fingers on the full-blown screen, and the magnification might have been closer to 200x than 150. So there was a considerable amount of spreading of the light on the screen. So here we are back to our normal galactic magnification of 75x viewing NGC 4485 and its brighter neighbor NGC 4490, which I am not going to center on because it's giving such a great view right on the screen. The brighter galaxy and larger galaxy NGC 4490 is a galaxy in Canis Venatici, magnitude 9.8, 6.4 by 3.2 arc minutes. A perfectly oblate aspect ratio 28 million light year distant galaxy, spiral with a bar in lowercase cd, which means well to the right on the spiral Hubble-Devoculair's morphological chart, and therefore a relatively youthful galaxy. Probably the best views I have seen yet. And I would like to point something out. The actual size of these galaxies on the screen is about the same size as it was at 150 to 200x. It's just that now at a lower magnification, we're able to see more of the galaxy, which is the justification for not over-magnifying galaxies in the first place. Very nice view of galaxy pair 4485 and 4490 to kick off the evening. Look what the intergalactic Mother Nature has brought forth. NGC 5195, galaxy in Canis Venatici, much further north, 47 degrees 16 minutes and 0 seconds, right ascension 1329.59, well placed, no obstruction of the aperture, perhaps the least amount of obstruction possible. Look at the spiralaceous nature of NGC 5195 and its neighboring galaxy. I suspect this is a Messier galaxy. I can't call its name right off the top of my head, but I have seen them through a telescope in the past. A 6-inch telescope. On a really good night, you can see those spiral arms. NGC 5195 is magnitude 9.6, 5.9 by 4.6 arc minutes. Spiral with a bar, lenticular, with a lowercase a, meaning half removed from the lenticular class. 25 million light years distant. Given its apparent size, that means it's about half the size of our own Milky Way. So about 40 to 50,000 light years in diameter. This is the best view I have gotten of this galaxy pair. I just love that you can see the spiral arm extending all the way out to the neighboring satellite galaxy. What a great view. And I think this is going to pretty much wrap up our views given the designations. Possibly 53 will be able to turn up. Let's go ahead with that next. But just fall into this beautiful spiraling arms of NGC 5195 in Canis Venatici. While our first four galaxies, NGC 4485, especially 4490, and 5195 and its neighbor, could easily have been seen by Charles Messier with his 3-inch scope back in the 1780s. This one, NGC 5353, galaxy in Canis Venatici, at magnitude 11 is probably a bit too faint. 2.8 by 1.9 arc minutes, football-shaped lenticular spiral, 106 million light years distant, puts it at about 75,000 light years in diameter. We're at right ascension 1353.26, declination 40.16. Once again, I'd like to point out that we are recapping a series of galaxies that were done during the lunar cycle but at higher magnification. not to be verified, however, because I don't know when the shift occurred in terms of the E-zoom function turning, it's activating itself. Could have fumble fingered that at any point. But what we're seeing now is NGC 5557, Galaxy in Boötes. Magnitude 11, 2.4 by 1.9 arc minutes. Elliptical class 1 at 151 million light years distant. Puts this probably a little more than 100,000 light years in diameter, which is actually quite large for ellipticals, which tend to be rather compact. We're at declination 36, 29, 30, 36. Right is, I've heard 36, 24. Anyway, right ascension 14, 18, 23. And we also have a space bug that's making huge galactic leaps in a single bound. Before we do an equatorial flip to show that, get some views of the Herculean galaxies, etc., and some in Corona Borealis, thought I'd take a look at NGC 5558, aka 5552. It's a magnitude 15 spiral, 0.8 by 0.3 arc minutes, 350 million light years distant. We are now in Virgo, 7 degrees above the celestial equator, and I'm hoping we're getting a view. It's a little more difficult for me to see the screen at this angle, but there we go. I'm going to go ahead and see if there's any more adventitious galaxies that we might like to check out as we continue to look at this one. Here's a 15.3. Let's go to that, just to probe at the limits. NGC 5563 is another galaxy not too more distant from the last one in Virgo. This one's slightly fainter, 15.3 magnitudes, 0.7 by 0.4 arc minute, relatively oblately presented, pure spiral, unclassified, 323 million light years distant. We are at right ascension 14, 20, 13, declination plus 7 degrees and change. And that will conclude our looks at western-facing galaxies. And let's flip the scope over and go east. I thought we'd start with a little view of Messier 92. Of course, Messier 92 is the fainter of the two Messier galaxies in the Great Hercules cluster. Looks quite brilliant up there on the screen. Perhaps we'll have another look at its brighter confrere later on, but there is our view. I've given out data on it before. I might as well do it again. Messier 92. Globular cluster in Hercules, magnitude 6.5, 11.2 arc minutes in diameter, 26,700 light years distant, pretty much the same distance out as Messier 13. We're at declination plus 43 and change, and right ascension now, we've made the leap to 17 hours, 17 minutes, and 7 seconds. That is a sweet look. What we might like to notice here is not a galaxy, but a planetary nebula. NGC 6210, planetary nebula Hercules, magnitude 9.7, but small, 20 by 13 arc minutes. This one probably could use some magnification. The central star is magnitude 12.5, and it's at a distance of 7,400 light years, which is a little ways out for planetary nebula, and actually quite bright. Of course, you know a planetary nebula is a star in the late stages of its life, exiting or having already exited the main sequence. Basically, its surface temperature has gotten so hot it's ionizing a tremendous amount of the photosphere and throwing it off into the depths of space. You should easily recognize that this cluster is brighter than Messier 92. It is in fact the Great Hercules cluster, Messier 13. May seem to some to be a bad luck number, but 13 is a good luck number for those of us who like to probe the night sky. Messier 13 is a globular cluster in Hercules, magnitude 5.8, so about twice as bright and a little larger at 23.2 arc minutes than Messier 92. 25,100 light years distant. It's at 36 degrees further south by about 6 degrees than Messier 92. We're getting a very unobstructed view of this spectacular globular cluster on what is turning out to be a surprisingly decent night of seeing despite high, thin clouds. Now there's a reason why we came to Messier 13. First, because we have a galactic neighbor that we're about to hop to next. Here we see Messier 13's nearby galactic neighbor, NGC 6207 in Hercules. Magnitude 11.6, 3 by 1.2 arc minutes, gives the view of an sort of an edgy-on spiral. Spiral of the class C, so a relatively immature spiral, 38 million light years distant, probably somewhere around 40,000 light years in diameter, giving its apparent size. Now, one thing I would point out about this 11.6 magnitude galaxy, I have seen it at the eyepiece of a 6-inch telescope. So magnitude 11.6 to even 12th magnitude galaxies are detectable on direct vision and not necessarily using aversion, which adds another 0.8 magnitudes to a telescope's reach. NGC 6239 is even more edge-on than 6207 and slightly fainter. Magnitude 12.4, 2.4 by 1.1 arc minute, spiral with a bar in lowercase b, 46 million light years distant. Of course, this galaxy is in Hercules. It's at plus almost 43 degrees in declination. And frankly, we could probably go another couple of degrees further north and still not be blocked. Galaxy's quite present in its edgy-onness on the screen. A good look. Here we're about to get a view of something other than a galaxy. This is another globular cluster, NGC 6229. And as a globular cluster, I've actually collected some data in advance. Its blue-violet magnitude is 9.38, while its yellow-green is 9.86. A complete reversal from galaxies where typically the visual magnitude is brighter than the near violet magnitude. It's got a near infrared of 7.98 and a further infrared of 743 and 733. It's that inversion of the magnitude of the violet the blue-violet versus the yellow-green that caught my eye when I looked up this data. I do not believe that that is standard for a globular cluster, but I will take more opportunities to review that kind of data in the future. NGC 6166, another galaxy in Hercules, magnitude 11.8, 2.2 by 1.7 arc minutes. It is an elliptical 2 spiral with a P, and that typically means peculiarities. There does seem to be a little bit of extension on this galaxy. It is 415 million light years distant. Now, at that distance, it puts it somewhere around 225 to 250,000 light years in diameter. This is very, very large for an elliptical galaxy. And perhaps that peculiarity comes down to the fact that it may have recently absorbed a neighboring galaxy which spiraled in the mating dance of galaxies, two became one. We're at right ascension 1628-38 and declination plus 39, 33, 0, 4. And there is our view of this nearly half billion light year distant NGC 6166. Okay, here we have NGC 6389. Now this is the furthest south of the galaxy so far we've encountered in Hercules. Magnitude 12.1, 2.8 by 1.9 arc minute, spiral with the lowercase bc, so 2.5 times removed from the lenticular class. It's 142 million light years distant, puts it a little larger than our own Milky Way galaxy. I'd say somewhere around 100 to 105,000 light years in diameter. As I mentioned, it's further south. It's plus 16 and change degrees. We are now at 17 hours, 32 minutes, and 39 seconds in right ascension. And from what I can tell, it's a very nice field of stars accompanying this 142 million light year distant galaxy. NGC 6574, another galaxy in Hercules, is also NGC 6610. It's magnitude 12, 1.5 by 1.1 arc minute, spiral with a bar, lowercase bc. 110 million light years distant. We're just almost 15 degrees in northern declination, so we are once again in southern Hercules. Well, I've returned to NGC 6166 primarily because there's a whole spate of 66s, A through D as far as I can tell. So let me step you through them a little bit. 61, 66, and what I'm going to do is I'm going to jog the handset and we'll see it jump. I do believe this is our galaxy 6166 right there. I'm going to say go to. Let's see if it moves. No. All right. So that was where I centered it. Keep an eye on that location. As you recall, NGC 6166 was a magnitude 11.8 galaxy, 2.2 by 1.7 arc minutes. That was that elliptical 2 with peculiarities. If I go to A, we should see a little hop to a smallest magnitude 16 galaxy. Let's check it out. I heard one click, so might have you. So look in the position of 6166. I'll give you the data on 6166A. NGC 6166A, galaxy in Hercules, part of that 6166 group. It's magnitude 16, 0.3 by 0.2 arc minutes, lenticular spiral, 452 million light years distant. We're at almost 40 degrees north declination, but we're not getting any block of the scope. Let's move on to the next one, which is B. Now watch the little jump. NGC 6166B is magnitude 15.8 and smallest 0.3 by 0.3 arc minutes. Spiral with peculiarities, it's listed as 393 million light years distant, which is closer. All right, let's see if I believe there's a C. We're going to go to it now. One click away. NGC 6166C is magnitude 15.5, a little larger, 0.4 by 0.4 arc minutes, lenticular spiral, 387 million light years distant. And I do believe there's a D. Let's watch that one. Once again, a little click. Let's see if there is an E. A, B, C, D. No E. All right, so that was the 6166 series, and they were all pretty tight because I can see the originating 6166 right there, which probably put our last galaxy right about there on the screen. Well, I just shifted to the highest rating shutter speed, which is roughly 5 seconds for each of 6 image capture sequence overlays, to give you a view of what Messier 13 looks like, because what I really want to do is jump over to 6207 and give you an idea of what it will look like on the screen, how long it will generate. And as you recall, NGC 6207 is a neighbor, in the sky at least, of Messier 13. 6207 is, according to the Sky Live, has a blue violet of 12.19 and a visual magnitude of 1.65, which gives it about a 0.5 magnitude delta between the two. It's called the BV delta. It also has a per arc second average surface brightness of 22.66, which is fairly bright, not the brightest of the evening. That was 6389. So there is our look at this nearly edgy-on galaxy using the highest sensitivity setting. So I'm going to do one more thing. I'm going to boost this up to 44.8 so we can watch, see if there's any real change there. And there shouldn't be much. From 42 to 44.8 is probably only going to add about 0.2 magnitudes in reach to the galaxy. So with this little experiment, I'm going to return to the previous values and then give you that final view, for which I typically say carpe noctem.